around. When we think of motion, we often think of cars, bicycles, kids running, basketball bouncing, and airplanes flying. However, motion entails so much more. It is important to our lives and it impacts so many things that we do. Motion is the change in position of a body with respect to its surrounding environments within a given interval of time. An object is said to be in motion if its position changes with time. Let me ask this question. Can a chair move without any application of force? Come along with me as we find out. Hello and welcome to another exciting moment with ExamPadi. Our topic today is machine motion. And in this video, we will explain machine motion and its types. We will discuss linear and rotary motion and explain how the conversion of rotary motion to linear motion is done. Motion can be defined as the movement of a body or object from one point to another with the application of force. It can be described as the change in the position of objects, which is a common phenomenon in nature. The moon moves and we humans move from one place to another as well. It is also a common practice for various components of a mechanical system to move relatively to one another. The motion of an object is explained by its speed and direction of motion. If an object is at rest, the state is considered to be in the state of zero. By applying force, we can say that the object is in motion. Examples include needle of a sewing machine at work, the tire of a moving car, cycling, running, and so on. There are several types of motion, but we are going to be talking about two, which is the linear motion and the rotary motion. Linear motion can be defined as the change in position in a straight line. An example is the motion of the needle of the sewing machine or the motion of a crane being hauled by using a pulley. There are different types or parts of a mechanical system that exhibits this type of motion. This includes 1. The lever. It helps us to do work easily. Examples are the crowbar, the doorknob, and so on. It often has a pivot about which the lever turns. This point is called the fulcrum. An example is the crowbar. B. Linkages. This is an assembly of metallic bars in which each bar is connected to at least two other bars in an elbow or sliding joint. They are often used for converting linear motion to rotary motion and vice versa, or for converting a linear motion to another linear motion, but in the opposite direction. Application of linkages include bicycle brakes, cranks, and slides. 2. Rotary motion. This can be defined as the change in motion around a fixed axis, such as the motion of the blade of a ceiling fan or the tire of a moving car. The two types of rotary motion include A. One-way rotary motion. This is the type of motion that is strictly clockwise or anti-clockwise. In a one-way rotary motion, a reversal of direction can lead to the damage of such a machine. This allows continuous rotation and can only be brought to rest by the application of a brake. In some of these motions, reversibility may be required. For example, shaft of a moving car, train, or crane, while for others, reversibility may be dangerous and there will be need for barring. For example, circular saw for cutting wood and clock mechanism. These motions can, however, be controlled by a ratchet wheel. B. Reversible rotary motion. This is the type of rotary motion that can go clockwise and anti-clockwise. For example, in a vehicle, reversible rotary motion makes it possible for a car to reverse. A crane also has a reversible rotary motion which enables it to lift and drop burdens in its load drum. Function of the clutch in a car is to disconnect two shafts running at different speeds pertaining to the engine crankshaft and the gearbox shaft. Control of rotary motion. This involves the use of devices for initiating and arresting the flow of motion. These devices include 1. Brake, 2. Clutch, 3. Ratchets. Let's talk about brake. The kinetic energy in a moving object is absorbed by brakes because they are meant to control motion. This produces heat on the brake as the kinetic energy is converted into potential energy. As the brake absorbs it, the vehicle slows down until it finally comes to a halt. The different types of brakes include A. Disc brake, which is used in light vehicles. B. Drum brakes, used for heavy vehicles. C. External block brakes, used in cranes and winches. D. Internal shoe brakes, used for motorcycles and other small automobiles. 2. Clutches. These are devices used to engage and disengage two moving parts. A few examples of clutches include the friction clutch and the dog clutch. 3. Ratchets. These are devices that transmit motion only in one direction. Have you ever wondered how the conversion of rotary motion to linear motion occurs? This conversion takes place in the following machines. 1. Sewing machine. In some machines, it is necessary for a change from one form of the motion to another along its line of operation. For instance, a sewing machine will need to convert linear motion from the pedal to rotary motion at the wheel and finally to linear motion again at the middle area. 2. Piston crank mechanism of a car engine is another example of converting rotary motion at one point of an engine to linear motion at another point of the same engine. 3. Crank and slider. The crank and slider mechanism is used in certain machines. This mechanism consists of a rotating crank that rotates around its center and an arrangement of levers that act as a linkage to a sliding block constrained to execute linear motion at the end. In an automobile, this system is described as the piston and crankshaft. In a machine, the crank and slider device can work in changing rotary motion to linear motion and vice versa. Other examples of machines that can be converted from one form of energy to another are screw jacks, racks, piston steering system, crankshafts and cylinders, metal work table vices, woodworkers vices, pipe vices, G-clamp, and so on. Answer the following questions to test your knowledge of the topic. 1. Explain the term machine and motion and describe two types of mechanical motion. 2. Expatiate linear and rotary motion. 3. Explain how rotary motion converts to linear motion. We've come to the end of today's topic. I'll see you in our next video. Bye!